TTL Computer 2. Today we'll be taking a look at some of my work in the simulator, and we'll be looking at changes in the hex loader. We'll be taking a look at some cool changes that I'll share in a moment, and then we'll be taking a look at some of my work in support of our serial I/O card implementation. So first, let's take a look at, we'll be looking at the monitor, and let's just start this up. And we have our monitor going. Okay, so let's just do a question mark again so we can see these are our commands, and we can see that we have I for the Intel hex load. So if you recall way back when we first were working on the monitor, that the Intel hex load, I could only get that to work by manually typing in the hex file into the monitor, which was it's not practical for anything except for a very trivial program that we tested the hex file load out with. But what we really want to do is have an ability to paste the file into the terminal. But unfortunately, digital doesn't support that. And I even reached out to H. Neiman to see if that's something that he could do, and he said no, and he suggested something else, which is what I ended up doing. That I'll basically talk about at the tail end of the video. But all right, so what we're going to do now is I'm going to press I for Intel hex load, and that's going. So you can see that that's the actual text, the text of the hex file. And again, normally we would want to paste that into our terminal, but that didn't work here. All right, so the hex file is loaded now, and I know that the hex file is loaded at address 8000, and we can see that here. So what I'm going to do now is just do the go command, and we're going to go to the program that I just loaded. And we can see up here on our hex display, nothing is going on up there. And I'm going to do, I will do go now. All right. And we jumped to address 8000, and we can see that that program is going. And that program is just a counting program. It's just counting, counting in a loop as fast as it can go. All right. So, but one thing to notice here is that while that's going here, that our monitor is like stuck, right? It never returned. It never returned from the Go 8000, right? And that's kind of understandable. Our program, our computer is a single-threaded computer, right? It can only do one thing at a time. So we did the Intel hex load, we loaded the file in, and then we did a jump command to 8000, and it never returned from that jump command. It's just executing this program. So that's okay, but we can do better than that. Okay, so what I'm going to do is I'm going to stop this. I'm going to reassemble that test program, which I just did. And let's restart the monitor again. All right, the computer started. We have our monitor going. All right, we're going to do the hex load again, and that's going. And now we're going to do the Go 8000 again. All right, and we see up here nothing's happening on our hex display, and we're ready to do the Go. All right, so we did the Go, and now we see that our counter is going again. But let's come down to our monitor. And this time our monitor returned, right? It said thread queued, and then it came back to our monitor. So we still have a responsive monitor, and that program is still running and counting in the background, if you will. And our monitor is still functional, right? We can even do a dump command of 8000, and that's the address where the program was loaded in. And we could see that, right? We're doing our dump command, and that program is still running in the background and executing. So we're no longer in the single-threaded environment here. My TTL computer is now a multi-threaded computer. We can do multiple things at the same time. All right, so I'm going to do period to end the monitor. We could even do the modify command. Right, and again, that's still up, monitors going as well as that program. So that's just a preview of where we're going, and we're going to be working to make my TTL computer be a multi-threaded computer with a multi-threaded operating system, I guess, of sorts. So that's really, really cool. It's a really significant change from having just a single-threaded environment where the computer can only do one thing at a time. So I hope that you see that that's a major, major improvement, and is a preview again of where we'll be going and taking my TTL computer. And right now, so we're only running at 50,000 hertz in the simulator. My TTL computer the hardware is running at 4 megahertz. So it's going to be, is much faster than this. And we'll be able to do the two things, run multiple threads at the same time comfortably. But we'll have to wait and see on the hardware exactly how much usability we can get out of that. But right now, the threading capabilities as they are defined in the simulator is that my TTL computer in the simulator can run up to 10 threads or 10 things at the same time. Okay. All right. So that's my work in the simulator. We have the Intel hex file load working, which is what we're going to need to get programs onto our hardware when we're that far. And we also have, the start of the multi-threading environment for my TTL computer. All right. So let's stop this. All right. So now we can take a look at some of the work that I've been doing to support our serial card. And so here again, you might be looking at this and saying, hey, we're kind of missing a couple of things. And in fact, we are. We're missing our monitor device and we're missing our keyboard device. But you say, well, how could that be? They're not there. We were just running the monitor, and the keyboard and the monitor were both working fine. And that's because I've started implementing the serial card. And just like our other hardware initiatives, the two programmable logic arrays, the two GALs that we did, where we built those in the simulation first before we realized them in hardware, right? I want to do that same thing with the serial card as best we can to fully implement that in our simulator first. Opened. Okay. All right. So this is the start of our serial card. And again, our serial card is just going to be an example of any of our expansion slot cards. So they're all going to have, this is going to be like boilerplate for all of our cards. We have our 16-bit address lines coming in. We have our data bus coming in, and we have our 4 control signals coming in: read, write, uclock, and our clear signals. Then we'll have our address decode chip that we'll use to decode the address. And in this case, the serial card is at 2080. And then we have our serial UART, the 16550. Now, this chip did not exist in digital. I had to, again, construct this chip myself within digital. So I started out where I was just going to model in the simulation, the chip itself and all of the pins, really just for the purpose of getting the wiring, proved out and corrected. But as I started that work, I said, hey, let's just do a basic implementation so this thing actually works correctly and it will be completely functional in our simulator. So that's what I did. So besides defining the pinouts and everything, the circuit is designed as well. So here's all of our pin configurations. And then I have really high-level implementation of the functional elements of the serial UART. I won't go into this really in any kind of detail, but it's I have enough logic um, to replicate the logic behavior for selecting the chip, for selecting the read and the write functions. And I also implemented, if you remember when we talked about our memory map update, we talked we talked about communicating with the serial UART and that my TTL computer interacted with the serial UART using 8 registers that are on board the UART. So I have implemented those 8 registers so we can read and write to the registers in the simulator. And some of the functional behavior for those things has been realized. So this is the serial write register, and if you write to that register, you can see it goes to our terminal monitor. This is the serial receive register, and you can see that this is hooked up to our keyboard. So that's why we had a functioning simulator with our keyboard and our monitor, even though those devices were gone from our simulation, because those are now implemented in the serial chip itself to again, replicate how this is going to function in our hardware, right? The computer is just going to be interfacing with the 16550 UART, and that UART is going to be connected to, the monitor and the keyboard, through the serial cable. But so that's the basic behavior there. This is going to work reasonably well. I might add a little bit more functionality to it, but it functions pretty well. You can read and write to the serial UART, and that will go to the monitor. I can read from the keyboard. I can also query the 16550 to see if there's any if there's data available to read or not. And I can also, there's some behavior to control 2 output registers on the 16550. And I've also implemented that behavior as well, because I'm going to use that on the serial card. Here we have these 2 LED indicators. I'm probably going to use these to indicate when something is being, transmitted, or, one of these will be a transmit light and one of these will be a receive light. So we'll be able to see, activity happening on the serial card. And then we'll also be able to use those as our some initial, debugging steps when we first start, our first steps at trying to, test out this hardware once we plug it into the computer. Very simple thing. We'll just try to turn on and off these LEDs to see that the communication to the 16550 is working correctly. Okay, and here is our oscillator chip is going to be on the serial card, and will drive the baud rate clocks for the serial UART. Okay, and then here is this is just a mock-up of the FTDI, which is the actual cable that you use to interface a USB port to to a digital circuit, which is what we'll be using to actually communicate between the computer, our laptop computer with the terminal, and the MyTTL computer through the FTDI cable. All right. So that's it for today. We've taken a look at our updates to our monitor for our Intel hex load. We took a look at the start of our multi-threaded environment capabilities in the simulator, and we also looked at our implementation of our serial card and using the 16550 serial UART. So that really sets the stage for starting to move forward with the physical design for our serial card. So that's it for today. Until next time, thanks for watching.